Hello, welcome to my Unity tutorial for creating a third-person camera controller system utilizing a gamepad and including options along the way and collision detection. Make sure if you're using a PlayStation 4 controller like I am, make sure your left stick Y is set to invert and your axes are set up correctly set for whatever controller. If you're using a keyboard and mouse, you can replace left stick X and left stick Y with horizontal and vertical, and right stick X and right stick Y with mouse X and mouse Y. So let's begin. We have a movement system just for moving the player around. So let's go on to the camera controllers. Firstly, we're going to get our basic functions up here. Not functions, our basic floats and stuff. So we're going to start with a private vector 2. So this is all the basic things that we need. Variables, that's what I was trying to say. So we're going to get our V2 input, which is what important, so we map our stick onto that. Very important. Then we're going to get our maximum angle for the camera to rotate, and then we're going to get our minimum angle as well. And we're going to use this setup later. Then we're going to get our distance. So this is our distance from the player, no, from the camera to the player. And we're going to get our max and minimum distance. Okay, now we're going to get our player object. I'm going to call it GeoPlayer. And then we're going to move on to our private vector 2. To camera vec. Now this camera vector is going to store our current direction vector, since we're going to be adding and taking away from it with the V2 input. Okay, and we're going to get ourselves. We can move on to the private things now, things we don't really need to see in the editor. So we need a private quaternion called QRotation. QRotation private vector 3 called V3 direction, and another private vector 3 called V3 camera direction, which is the direction from the camera from the player to the camera. And now we can have all of our settings here. So we can have another serialized field. We'll put this as a private float f sensitivity equals 1.0f, and we need to set a range for this. Since we're not going to be using a UI for this, we're just going to use the editor, so we're going to need to set some ranges. Next, we're going to have our first private bool, which is going to be B3 fixed camera. Right, that's gonna that. And we're gonna make another bool, which is gonna be B stop rotation. So this is going to stop the camera from rotating, and fixed camera is just going to have the camera track around. You can combine the two to have a camera in a fixed location that does not rotate. And finally, we're going to make a private enum called invert options. We're going to inside we're going to include options here as none, X, Y, and both. And then we're going to serialize. A private version of that called invert options. Okay, wonderful. Now let's get into the start function and start our values up. So our distance will equal 10.0f, and because of this, our maximum distance will be setting it from here 10.0f. Maximum angle will equal 89.0f. Minimum angle will equal 0.0f. If it goes below, glitches out. If it goes above, it locks in place. Minimum distance will be 1.0f. Let's go back down. Camera vector can start at 0 as new vector 2, 0, 10. So this is the starting position of our camera. So back down into start, we can go geo player is game object, find game object with tag player. So this finds the first object with the player tag, which will be our player. Okay, we want our fixed camera to be false. Stop rotation to be false. Oops, false. We want our sensitivity to equal 1, just in case it hasn't been set up there. It has, but just in case it doesn't. And then for invert options, we're going to set to equals invert options dot none as our standard. Okay, now on to update. We're going to start with getting our V2 input. So we're just going to cache them in a vector 2. Okay, we're just going to copy paste this axis. Make sure I gotta make sure I actually change the X to a Y. Here we go. And if you want, you can also use mouse X and mouse Y. Let me just put that there, just to keep in track of that. Okay, now we want to get our V3 camera direction. So we just want our position and take that away from the player's position. Now take the player's position away from that. We got our direction to the player. Moving on, we will start with our v2 camera vec.x equals v2 input.x. We'll put this in now. We'll times it by our sensitivity. So what this will mean is that when we've got our sensitivity, it'll all be set up so that no matter what the sensitivity is, that's times by this, and it can't be 0. Now we want to use our enum, so we'll make a switch case based on our invert options. Okay. Case invert options dot none. This is going to be this, and we want a break at the end. Now we can just copy paste this into the rest of it. It shouldn't be like that. It should not be another case of those. There we go. Let's copy paste this in. We want X, Y, both default. So this is our default's going to be easy. We'll just replace this with default. Okay, now we can just go minus for minus Y, minus X, minus, and then remove case as well. And there we go. We have our whole setup. So now what's next? Well, now we need a new function called update camera. We're going to call that, and then we're going to actually declare it underneath here as a void. Okay, so in this we're going to do all the main code for the camera. So we're going to start with our v2 camera vector. We're going to just clamp this using mathf.clamp to make sure that it is between our minimum and maximum angle. Nice. Okay, and then we're going to use an if-else loop, an if-else statement even, for our f distance to make sure it's not greater than max. And if it is less than that, we can just set our f distance to minimum. There we go. Now, you could use a clamp for this. However, with all the editing we're going to be doing to distance, I don't really feel like it needs to be changed from if else at this point. So at this point, let's set our v3 direction vector. It's just going to be a new vector 3, 0, 0, minus f direction, f distance even. So that's our direction, which we'll be using later on to transform the camera. So now, if b fixed stop b stop rotation is false, then we will start with our cotillion q rotation, which will equal cotillion.euler. Due to the Euler angles being different, it's going to be v2 cameravec.y, v2 cameravec.x, and then 0. Now, if b fixed camera is false, then we can start with the altering of it. Game object dot transform dot position, which is our camera's one, is going to be our player's transform position plus q rotation times by v3 direction. Now, because this part needs to be here, so once again we're going to need to call b stop rotation. Is false. Since it needs to be at the end, since all the transformations have ended, we can start with our game object dot transform dot look at. We want it to look at the player, so geo player dot transform dot position. Okay, moving on. We now have that sorted. Now let's start with our collision check. So we want a boolean for our collision check, and this is just going to be a raycast hit called hit, and then we'll start with the raycasting. So if we raycast from the player's starting position, going in the direction of the camera, outputting to hit, and with a distance of our current distance, f distance, then while this is true, so I'm going to start with a while loop. While that's true, then we can start decreasing our distance by 0.1f every single time this is true, and then we can return true. However, if that's not the case and nothing's hit, then nothing's colliding, so we can just return false. Now, we also want to push the camera as far back as we can, because otherwise it'll just be pushed forward and never go back. So we want a void pushback function, which is very, very simple. Although you wouldn't, I didn't think it was simple when I tried it, but it's surprisingly simple. You just get another raycast, and then you take the raycast from the player to the camera, and you replace f distance with f max distance, so it goes past the camera if it's not there, and if nothing collides with the camera with the ray, then that means we have as far back as we can go. We can just set our distance to max distance, just like that. And if there is something colliding, then it's even simpler. We just go f distance is our hit, collide is just the distance to wherever we've hit, to the point we hit, and it's done. Okay, so we've got our now we've got our camera system with all these different settings. Let's go test it. Okay. Just gotta wait for Unity to finish loading. Let's go on with those materials. That should be fine. Alright, let's do this. So we're going to start by... Oh, I see our first problem, I think. Here we go. These need to be plus equal, and that should be the only issue we've had. Just put these in, and we're done. We should be able to test this now and see if it works, which it should. Let's just import those scripts. Please. This is the materials, I think it is. Not related to the code. Alright, let's test this out now. Should work fine. Yep. Oh. Oh, what's going on? Ah. No, it should be working. What have I done wrong? Forgot to call it. So we got if collision check is true, is false even, then we just call pushback. And just open up Unity. Okay, so the axes are slightly inverted. It's because the controller inputs are slightly inverted as well. But that's easily fixed by either going into the settings or just changing them in our invert options, which I'll show off if it still has issues. Oh. Yeah, here we go. Camera's colliding. Does it go through the tube? It goes through the tube wonderfully. A bit iffy, but that can be fixed with some lerping, I believe. And if we set up both our inverts properly, now it works properly. Fixed camera, wonderful. Stop rotation, doesn't rotate. Sensitivity, yep, all works fine. Okay, thank you for watching this tutorial. I hope I've helped you in some way. Thanks for watching. Bye.